Yeah.
Okay, okay, that will be good then. And okay, let me share my screen also. And then let's get started. So let's see what we exactly have in these. Okay, so let's just finish this part and then we can start with some backtracking questions. We can start with hash maps also. Okay, I'll share my screen. I guess it's right. Okay, for some of the remaining question in BST2, so let's have a look. Last day, what we did is we created our BST class. Okay, so class-based problems can also come. So some of the companies, what they do is they will say you that I need a class and these are the search function, insert function, deletion, and all these kind of things. Okay, so you have to develop a class. Now, how it works is you have to decide what will be the data members. Okay, data members का क्या होंगे and what are the functions, which functions you have to keep public, which functions you have to keep private. So these things, these are the decisions you have to make. ठीक है, जैसे कि last class we did um, like some public functions were there, insert was there. For inserting we created a insert helper function. ठीक है, insert helper function we created. Then we had our smallest element kind of function, and all these were there. Okay, so this decision we have to take in case of class based problems. Okay, next is delete also. So there is a delete in BST thing. Okay, so we already implemented. That was a good discussion. So I hope this deleting a node from binary search tree insertion, these part are clear. So you guys are clear with this. If you need any like repetition or anything you want me to revise, you can just feel free to ask. Okay, otherwise let's proceed. The question is level-wise linked list. Okay, so level-wise linked list is there. Now, level-wise traversal is something which is different from what we have did till now. Okay, so moving on. Till now we have either we have used recursion. Okay, so either not, like mostly it is recursion itself. Okay, so you just go for traversal on the right hand side, left hand side, and that's it. Now, level-wise traversal of a tree is a bit different. Okay, so level-wise traversal of tree is a bit different, which we all already discussed in binary trees, I guess. Okay, but the point is now we have to. This is also an easy one. Okay, but let's see how we can proceed with this. So now we have to take out the लेवल वाइज ट्रैवर्सल इन अ लिंक लिस्ट. ठीक है, सो आपको एक लिंक लिस्ट प्रिपेयर करनी है एंड दैट विल बी लेवल वाइज लेवल वाइज ट्रैवर्सल. ओके, ठीक है, लेट्स सी हाउ वी कैन डू इट. आई विल गेट माय पेन. गिव मी अ मिनट. Okay, so suppose that we have a tree. Okay, let's say that we have a tree 20, 8, then we have, let's say, 23, we have 5, 6, then we have finally 21 and 24. Okay, now I need to create a linked list. Okay, with the and which will be level wise traversal. Okay, that will be level wise traversal. And what do we have to return exactly? Okay, so we have to return array list of linked list head. Okay, so we have to return each head. Okay, so you can just return the head. Now, how do we do level wise traversal? Can someone explain how do we do the level wise traversal? We already did in binary trees. Okay. How do we do the level wise traversal?
28, 23. Using a
Oh,
queue data structure.
yes, using Q data structure, we go with this. Okay. So what we say that key insert at 20 after this,
After this, we'll pop it up and
pop it.
check if the left and right exist. If they exist, then we'll insert into the queue.
Okay. So check left, check right, exist, insert them. Okay. Next.
Again, pop the first element,
Okay.
then check the left and right. If they are
Uh,
present, then you can insert it.
okay. So 8, check the left and right. So which is 5, 6. Again pop it
Yeah.
and insert 21, 24. Make sense?
Yes.
Okay. Now there is one issue. So this is very correct. Take a correct approach to get levelized traversal. But for this question, we need separate linked list for all levels. Any guesses what we can do? Because I cannot distinguish. I only have level wise linked list. If I go with this approach, I will not be able to distinguish which level it is. How to do that?
We can traverse the size of the queue,
We
like
can
for each level.
traverse the size of queue
We are using a for loop. We can
using.
find the current size of the queue and then we can traverse that anytime.
Okay, but when to traverse?
Mm, Like when we push the first element, then we'll
Hmm.
find the size. Size will come one.
Okay.
So we'll get to know that the first level is of one size.
Hmm. Okay.
Then we'll check and put the two elements left and right. Then again we'll find the size. The size will be two.
Okay.
Then on third level, four elements will be there. Size will be four. So in that way.
Okay. So first, very correct. Insert first element, measure it. For second, insert both of them, measure it. But when we move to third, how will we know that how many nodes to pop before we measure the size? We have also to eliminate these two elements, right? So we have to include the count of these two also. We have to.
Yes, yes.
Are you getting the problem? Okay, size approach is very correct. Okay, see this. Can I do one thing? I will include identifier whenever I include these two elements. Whenever I include 20, I will put a null. Okay.
Yeah, we can do that as well.
Okay.
Yeah.
Now, whenever I hit a null, I will include one more null. I will pop this. I will insert element. Check it. No null. Will not insert the null. Pop this. Insert its child. But for third one, I will receive a null. So I will insert a null. Make sense?
Yes.
Okay. So by this, we'll have all the levels. Guys, all of you like getting the point? Okay. Let's implement this. Okay. It will take just 2 3 minutes. Then maybe we can move to our hash maps today also. Okay. Okay. Let's completely get over with this and then start hash map. Okay. Wherever exactly. So I will say there's a linked list node class, and we have all the classes over here. So no worries. I can say let's take up a queue of integer. Let's say q is equals to new linked list. Okay. Okay, so we just import linked list and import. Okay, that's it. Next part. The first step, insert the. So what to insert at the first?
Root.
Okay, so we have to insert the root. Okay, thank you. So then one more change. Okay, the change is I will not store the integer. I will store the node. Make sense, guys?
Yes.
Okay, so आपको इंटीजर नहीं स्टोर करनी है, आपको पूरी नोड स्टोर करनी है, so that you can get the left and right. अच्छा, so once this is done, I'm saying that insert a null. ठीक है, आप यहाँ पे null insert कर दो. So first thing first, you have an idea for this linked list. You just have an break it after one level. So first level will be after the root itself. ठीक है, तो इसलिए मैंने null insert कर दिया. For the second one, I will create a array list and let me copy this one. ठीक है, इस पे एक नया array list बनाएंगे and something the sort of just a second. ठीक है, so this is the array list और एक नया array list बनाएंगे. Let me copy this one. ठीक है, okay, and also node also to be created. तो पहला लिंक लिस्ट तो सिर्फ एक ही हेड होगा, देयर विल बी अ सिंगल वन. So let's create that, or let's do it while popping. That will be more good. Now the point is, whenever we talk for stack, तो हम recursion की बात करते हैं, ठीक है. But whenever we talk about queue, so हम loop से भी काम चला सकते हैं, ठीक है. Because it is first in first out. मतलब उससे भी नहीं, we can use the traversal. ठीक है, traversal की चीज़ें देख सकते हैं. There is no issues. So we'll measure the empty. So until and unless this is empty, I will traverse over the queue. Okay. First part. First part. Let's take the not in this one. Let's take the integer. Sorry, a root out of queue. Okay. So I will say node बराबर q dot pool. Remember, it's not a pop. ठीक है, pop नहीं है, pool function है, right? Pool is only there in queue, or pop. Pool is there. Okay. Next one. So this is the polling. Okay. So I have popped the first one. Okay. I have popped the first node. Okay. I have popped the first node. Next will be whenever I pop something. So whenever I pop something, I have to insert it in the linked list. Okay, so let's get back here and discuss a little more. So whenever I am trying to pop it, okay, सबसे पहले तो level wise traversal. For that we are using queue, and we are saying that we'll insert the root and we'll pop it and we'll insert its two child. Between that, null will be there at the intermediary places. Okay, so when we have 20 over here, so I can say that while I pop 20, I will include it in the linked list. Okay, I will include it in the linked list. Let's let the loop run again. Whenever I hit a null, okay, whenever I hit a null, what I will do is I will declare that this linked list is complete. Okay, I will declare that this linked list is complete and assign the head, store the head in the array list. Okay, this linked list is complete. First level is complete. I will assign the head in the array list. ठीक है, array list में इस head को push कर देंगे, and in the same null I will replace this. I will replace this head. ठीक है, मैं इस head को new linked list से replace कर दूँ. Okay, so I will replace this with a न्यू लिंक लिस्ट, ठीक है। सो आई विल डू दिस। What I'm saying is कि जैसे लेवल कंप्लीट होगा आई विल स्टोर द हेड इन array list and I will reinitialize this head. Make sense guys?
Yes.
ठीक है। Okay, so I pop this and I before this I will have linked list head and linked list tail, ठीक है। head होगा और tail होगा। So um, let's say head, ठीक है, equals to null and tail is equals to null, ठीक है। That's what I have, and I can say that if whatever I have popped, okay, if whatever I have popped is not equals to null, we'll discuss this one now. Elsewise, if this is not equals to null, do something. We'll see what to do. Elsewise, I will whenever I pop it. So can I say that whenever I pop something, can I say that if my head equals not equals if head equals null, I can simply do one thing, which is new node. Okay, so create a new head with the data node dot data. Okay, so if my node is not null, so there will be two cases, either it is null or it is not null. Okay, so first case first, if my head is not null, if the node is not null and the head is null, so I will make a head. Also, I will make a tail. Now, if this is not the case, can I say that tail dot next barabar new, not the complete one, something like this, and I can say tail is equals to tail dot. Do you guys agree with this? Is this logic clear?
Yes.
This has nothing to do with the traversal. This is sorry, linked list creation part. अगर head है, so insert the new node to tail because that is how it works, or shift the tail to next one, the new inserted one. अगर head ही नहीं है, the linked list does not exist, so create a new linked list with the head and the tail will be the same head. So ये तो हो गई. This is when we have node not equals to null. ये तो के लिए ठीक है. Next part. नेक्स्ट पार्ट इज आर लिंक लिस्ट पार्ट इज डन, ठीक है। लिंक लिस्ट का पार्ट हो गया, अब क्यू का पार्ट कर लेते हैं। सो विल से दैट क्यू डॉट, ओके, फर्स्ट चेक इफ नोड डॉट लेफ्ट node dot left not equals to null, so I will say q dot add node dot left, and the same goes for our right also. Goes for left, goes for right. That's it, I guess. Okay, so node not equals to null के लिए सिर्फ इतना ही है, ठीक है। So this is what we have. Create the linked list. Okay, take care of the linked list and take care of the node to be inserted. That's it. Now, when there is null, ठीक है, what we decided is कि if you are getting this, ठीक है, so if you are getting, let's say 20, then we put it to linked list, ठीक है, put it to the linked list, ठीक है, and add its child to the queue. But the point is, whenever you hit a null, it means that it is indicating that like the level is over. ठीक है, so level over हो चुका है. इस head को array list में store करिए and reinitialize this head. So this is what we have to do. Store this head into array list and reinitialize the head. ठीक है, so let's quickly do it. So I will say array, uh, yeah, array list dot add. I will add the head over here, A, and I will make the head point to null again. Also, also, okay. So I just add the head to array list, and I will make it null again. Next point will be whenever I see a null, okay, whenever I see a null, so there are two cases here inside null also. There are two cases, यहाँ पे भी दो cases होंगे. One, we have more elements, so this null we have met. So either there are more elements in the linked list, or we will meet null at the end also when there is no element in the queue. ठीक है, so first case first, let's see कि have if if the um, queue is empty, ठीक है, queue is empty, अगर queue empty है, so what to do? Can I say that break? This was the last null, last level, that's it. But if the queue is not empty, I can say that queue dot add null. Are you getting the point, guys?
Yes.
Okay. So I guess that's it for this question. Nothing more we have. Okay. The last thing, return array list. What we did? One queue is there, which is holding the nodes. One array list is there, which is holding the heads. We added the root, we added the null. This null is marking one level is complete. ठीक है, तो पहले लेवल में तो सिर्फ root है, so this is one level. Now my linked list, I have only two of them, and that's it. That's enough, I guess, because what I will be doing is, okay, is it empty or is empty? What is the method name? Not sure.
Is
Let's
empty.
is empty. Yeah. Okay. Thank you. So it is empty. So when it is not empty, now we pop the element. So अगर वो null नहीं है, right? It means that is not null. यानी level की ending नहीं है. It means that go as we are going. ठीक है. Head null है तो create a head. Insert in the tail. अगर head is not null, then do this. ठीक है. So else. ठीक है. Either this or this. Or I guess okay, not needed. Not needed. Sorry, it's not needed, right? अगर वो if हो, no, or it's needed. Yeah. Will caught up in the case where this will also be running. Okay, so let it be. Okay, else safe here. Okay, now put the nodes in queue if it is there. Okay, now this was if we are getting it not null, and if it is null, null, then we have to add the head in the array list. Okay, and make the head null. Okay, and if it is empty, the queue becomes empty at this point, then break, otherwise add up. So that is what we have. Okay, we are returning the array list. That is it for this question. Let's try it out, and if you have any bug, we'll solve it. Okay, this is strange. Oh, if root is null, will return null work? So probably we are done with the BST one. हाँ, so pair sum in BST. Okay, so pair sum in BST. This is also one of good question. Anyone solve this question? Okay, let me tell what is the question first of all. So there is a binary search tree given to us, and what we are doing exactly is we go through the tree, okay, and we find a pair which can give this sum to us. Okay, there is a sum which we need, and it can give the sum to us. Okay, so how do we do it? Now, if I have this tree, okay, just try it out. Okay, very easy. Just try it out. The point is, and you have to do it in order of n. Okay, so you have to put some brains there. Okay, the point is they are saying that in a single traversal do this. Okay, if you remember, we just solved one question with a reverse in order traversal. This question was replace node with like some of greater nodes. Remember that question, guys? Replace some with some of greater nodes. Replace the node data. We we started from right hand side, and then guys, okay, okay, I guess that is in BST one we did also. Okay, so in reverse in order means like I need to, the question was कि we have to replace the node data. ठीक है, node data हमें replace करना है जो भी bigger data है हमारे पास. ठीक है, जो भी बड़े डेटा हैं, बड़े नोट्स हैं, उनके डेटा से इसको रिप्लेस करो. So I started from back because इसको रिप्लेस कर, so no one can replace this. ठीक है, because this is the biggest. इसको रिप्लेस करने के लिए आई विल रिटर्न द 24, तो दिस विल बी रिप्लेस्ड. आई विल रिटर्न 23, 24, समथिंग लाइक दैट. Okay, let me focus on this question. Pair sum in BST. How to do it? Let's say we have 10, then we have 5, 15. Okay. 3, 6. Okay, I need to form some pairs also. So let's say 17 and no, not 17, obviously. It cannot be true. Let's say 17 and 14. ठीक है, so let's say कि हमारे पास and the pair we want to create make sum 20. ठीक है, so ये 20 फॉर्म करें. So how I need to find pairs which will sum to 20. So how many pairs are there, guys? कितने pairs हैं हमारे पास जो 20 फॉर्म करेंगे? One is 5 and 15, and next two.
3. So 14 and 6.
Yes, so we have three of
17 and 3.
yes, correct. So we have three of them, and these can be. Now the whole and soul question says we have to find these pairs. Okay, so how many pairs find them? So what is the brute force solution? The easiest of them, create an array. ठीक है, in order array, have two pointers, one at this, one at this, and find the pairs. Isn't it order of n, where n is number of nodes? This approach, traverse in order, store in array, because in order of BST is uh, sorted in ascending order, right, guys?
Yes.
ठीक है, so array is there, and have two pointer approach, and order of n would be the time complexity. What is the space complexity? Space complexity is always calculated on extra space you have taken. So what is the extra space here? Order of n, right? The array we are taking, guys. Guys, are you with me? Like, we are taking the array, right? And two pointer approach, and we can just, so space complexity will be also order of n. Okay. 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 So the point is you can convert this to an array, okay, and you can just traverse with two pointer approach, and you can get the answer. Okay. The array we are taking here is of n space, okay, n nodes होंगे और n space होगा उसमें. So the space complexity is order of n. तो एक तो ये solution है, very easy solution, quick solution with the order of n space complexity. But the question says कि we have to use extra space of order of log n. ठीक है, log n ही extra space use कर सकता है. ठीक है, log n ही extra space हम use कर सकते हैं. Cannot use a array over here. So हमें कुछ और use करना पड़ेगा. Any guesses? What else can be used? Okay, ठीक है. I'm saying that कि अगर मैं इसका in order निकालूँ, so what is the in order? So in order says 3, 5, 6, ठीक है. Left root right, left root right, left root right, ठीक है. So ये मिला in order. But the question says order of log n can be used. So I cannot do one thing, and that is I cannot take the complete tree at a time. I do not have that option. So what I will do is, can I take two arrays or maybe two stacks for say one traverse at like one will traverse from this one, okay, in order way, and another will traverse from a reverse in order way. Okay, so one data will start filling from this side, and one data will be started filling from this side. Okay, now if we find that, okay, so this is 3, this is 17, so this is the extreme, this is the extreme. These two stacks are having the extreme. Let me remove this one. Now if the count matches, ठीक है, अगर पेयर बन रहा है, so that is totally fine, ठीक है. So if the pair is there, so it is totally fine, ठीक है. 3 and 17 are making the pair, so that is totally fine. Otherwise, let's say this is 18, 17 की जगह 18 हो, ठीक है. So this is 18. So what will be happening is I will just return. Okay, so I will since it's in reverse in order, so I will get this one. Okay, so I will get this one, which is 15. Okay, so I will go to 15. Now I will check this. I will check this. Now I can also do one more thing over here is, okay. Let me reiterate. What I'm exactly trying to say is, this is my stack, this is my stack. Order of login is allowed. Now order of login is height can be there, ठीक है, height हो सकता है. So if any time I have three elements or multiple of three तो चलेगा. It means that I can go extreme left where I will find the smallest element. I'll go extreme right, ठीक है, I will go extreme right where I find the okay, let me see, I've the battery is okay, 10% is there. So I will go extreme right, 10, 15, and then we have 17. Okay. Extreme left, extreme right. Now the point is, I will check two stacks. It will say 3, 17. Yes, the pair is there. Pop the elements. Okay. Pair is there. Pop the elements. Okay. But before popping, for the three left, we do not have anything in the left. So before we pop, we need to check if we have something in the right. When we are popping from the first stack, we have to check if there is something in the right. Right मतलब कहीं ऐसा तो नहीं यहाँ पे 4 है, that has to be inserted. ठीक है, but we do not have anything in right, so just pop it. Now 17 is being popped. ठीक है, 17 is being popped. So it is one thing is for sure कि right पे तो कुछ नहीं है, otherwise it would be in the stack. So I will check कहीं left में तो कुछ नहीं है, 16 or something, because this can contribute कर सकता है 16. No, it cannot contribute, but yeah, if there would be a 4 over here, so definitely the 16 would have contributed. मैंने क्या कहा कि मैंने कहा कि लेट्स गो एक्सट्रीम राइट, एक्सट्रीम लेफ्ट. नाउ दिस 3 was went out and I inserted the root. The 17 went out and I inserted the root. Again I have a pair. Okay, but this 4 and 16 are leaf nodes, so nothing much. Then I come with this. So जब मैं ये पॉप कर दूंगा तो आई विल कम विद दिस 5 and I will come with this 15. I again have a pair, so I will pop the 5, but before I pop 5 I will insert the right. Before I pop this 15, I will insert the left. Okay, so I have this 16, I have this 14. Now again I have a pair, so 6 and 14. Okay, I again have the pair 6 and 14. I will pop it out, but before popping it out, for this row, check if there is something in the check if there is something in the left. Before popping it, check if there is something in the left. Before popping it, checks if there's something is in the right. Are you guys getting the approach here? Every time I will have login elements. Remember reverse in order traversal. We already did this question. Okay, so there was a question, reverse in orders question that will help you solve this problem. We had it somewhere, I guess. Yeah, replace with some of greater nodes. ठीक है, सो गोइंग राइट फर्स्ट. ठीक है, राइट में ट्रैवर्स पहले कर रहे हैं. ठीक है, फिर लेफ्ट में जा रहे हैं, फिर रूट मतलब डेटा पे आ रहे हैं, फिर लेफ्ट पे जा रहे हैं. ठीक है, सो दिस द सेम लॉजिक फॉलोड ओवर. ट्राई दैट क्वेश्चन. ठीक है, दैट इज अ वेरी गुड क्वेश्चन. दिस did you get some insight like something with the two stack?
Yes.
Okay, yeah, it's again recursion. Everything is recursion. Recursion is the god here. Okay. Mm, let me get the charger. Give me a minute, guys. I'll come back. Okay. One more last thing, and then let's jump to hash map so that we can finish it today and tomorrow. Okay. Pass some route to live. This is easy one. This okay. Uh, okay. So sorry, it's binary two. That's what I thought. We have already done this. Where where are we? Pair sum in BST. So ठीक है. So this is what I'm doing, right? So you can just have a quick peek. So we have two stack, okay, something just popping, pushing for S1 go left, and all these are okay. This is easy. You just go through it. Largest BST, guys. I want you to know there are always two approach for traversing a tree. Okay, whenever we solve a problem related to tree, the most important thing while solving any tree problem is how to traverse, what will be the correct traversal order. Who knows this? There is nothing much in binary trees question, any tree question, ठीक है. So just traversal का खेल है, right? So आपको select करना है कि what traversal will be applied here, and rest recursion will take care, ठीक है. So that is the only thing, only decision you have to make. कैसे traverse करेंगे इसको, प्री ऑर्डर, पोस्ट ऑर्डर, इन ऑर्डर, whatever it is, ठीक है. Whatever can give you the like solution. Now, also there are two more things for traversal. Given okay, I'll just read the question and I'll say. Given a binary tree, find the largest BST subtree. Okay, binary search tree subtree. We have to find a subtree, मतलब part of a tree. That is, you need to find the BST with maximum height. Okay, you need to find a BST with a maximum height in the given binary tree. Binary tree है, BST नहीं दिया हुआ, binary tree दिया हुआ है, and you have to find the binary tree. You have to return height of largest binary search tree. So have to return the height of largest binary subtree. So ये आपको करना है कि what would be largest binary subtree. For example, we have an example over here. Let's pick an example. So it is 4261357. 4261357. 4261357. Okay. Okay. Um, so we are going to find the binary subtree. This is already a BST. Okay, this is already a BST. Not that of a good example, but yeah. This- The point is, I have to tell the maximum height and tell that it is a BST. I can say that BST with root 4 ये एक BST है. This decision I can only take if I look downwards. ठीक है, ये डिसीजन मैं तभी ले पाऊंगा if I look downwards. क्यों look downwards? I need to make sure that 2 and 6 follow the BST property. मतलब कि 2 the left one should be smaller than the root, और 6 जो है should be greater than the root. ठीक है. But the problem is this enough? Is the check enough? If I check that my left node is smaller and my right node is bigger, I'm a BST. Is this check enough, guys? ये check enough है क्या? Or something else I have to check? Guys, अगर मैं कहूँ कि this node is smaller, this is bigger, so is it enough? I can declare it a BST. If I have to do something else, if I'm standing at this point, yeah, I check this and this. Is it enough? I cannot say that.
We need to check the with the root also.
The below root also, right? Sorry,
Yeah.
node also.
Root.
Yeah. So I'm standing here and I just check this. Okay. So I cannot say that it is a BST. But if I stand here Can I say that it is a BST or not? Yes, I can say that, right? Why can I say that? Because if I go from downwards, if I go from downwards, I know that they have nothing in for them, but I can at least declare this as a BST. I can declare this as a BST. If I declare this as a BST, this is a BST. Also, this root is lies between these two roots. I can declare as a BST. Make sense, guys? How many of you agree with this? So can I confirm looking downwards or can I confirm looking upwards? Guys,
Looking upwards,
yes. So this we call, what do we call this approach?
bottom up.
Yes, so we call it bottom up. Okay. So this is what we are going to follow. Make sense, guys? Okay. Okay. Should I solve it or should we move to hash map? This is pair based problem which we already did in case of maximum height and diameter. Sorry, diameter of the tree. Okay. The only thing I wanted to know you guys is we have to follow the bottom up approach. Okay. So kind of you can say backtracking. Okay. First traverse downwards, and while returning, you have to return the answer. Okay. So this is what you have to do. Try it out. It is very easy. Nothing like fancy we have over here. Okay. So, any issues till now in like binary tree and binary search tree? Any issues, guys? You want me to discuss like any conceptual, like not the direct question. Obviously, solve it first, then we'll discuss. Any issues in binary tree and binary search tree? Okay. So I see if interviewer gives you easy to medium question, okay, and trust me, like for solving hard question, there will be coding challenges. In the interviews there is no hard problems because the interviewer does not have so much time that for himself and for you. Okay. So if there is a hard challenge, hard problem that is going to come in assignment round itself, the evaluation round, it will never be coming in your interview. Now interviewer will ask easy to medium problems. Okay. So also it depends on which position you are applying, so that is also one thing. If you are applying for DSA roles, then you can expect these questions. Otherwise backend with like very high position, then you can expect for front end, and for normal backend I don't think they will reach at this point, but yeah, maybe. Okay. So this is strategy, guys. Okay. And probably we are moving from the to the topics, the end topics. Okay. So I hope you guys and will be done with this. So that let me confirm who is taking Webly. Okay. Now we'll see some of the methods over here. It will be a quick revision for me also. Okay. मैं भी revise कर लेता हूँ. So hash map. Anyone wants to like give a quick idea what is hash map? Why we use it? And the first question is always there. Why we choose any data structure? So why do we have different data structure, guys? Who wants to answer this question? Very very basic question. इतने सारे डेटा स्ट्रक्चर क्यों है हमारे पास? एरे से भी तो काम चल ही रहा था. So why linked list, trees, array list, queue, stack? Why do we have these? Now hash map. ठीक है. द पॉइंट इज कि हमें करनी थी आइदर द सर्च ऑपरेशन, आइदर इंसर्शन, आइदर डिलीशन, आइदर सॉर्टिंग. ठीक है. So these were some things we have to do. तो ये हमें फॉलो करना, आइदर सर्च इज ऑप्टिमाइज, आइदर इंसर्शन एडिशन डिलीशन, सो इन सब में से कुछ तो ऑप्टिमाइज हमें करना है. And if you look at the data structures, some of them have some things optimized, but not a single data structure has everything optimized. ऐसा नहीं है कि सर्च भी है, इंसर्शन डिलीशन, all things are there. That's not the case. इसीलिए we are studying different data structures. Now, hash map, what it says is, okay, someone wants to say like what is the search time complexity in hash map?
Big of one.
Correct, very correct. So this is, hash map is optimized for search operation, right?
Yes.
Okay. So that is the basic idea behind every data structure, like why we are using. Okay. That's the question. Mm, okay. What we have here is clear clone compute computer present contains value. This is one we'll be using. Contains key will be using. Okay. So we'll say contains key, contains value. Contains key means we can check if the hash map has a sum key. Then get returns the value which is specified. The key is mapped. Boolean is empty. This is okay. This is Oracle docs. If you want to go through. Okay. Replace is there, and where is that put method? Okay, so here is the put method, right? So associate the specified element with a specified key. Okay. So what is needed? The needed things are hash, hashtag hash map. The needed things are put key value. We'll see once more. Get key, contains key, key is empty. Um, Key set, that's it, nothing more. Return type, I guess it's void. This is object, this is boolean, this is boolean, this is set. ठीक है. अच्छा, hasmap says let's have an any data structure, array, linked list, whatever weight. Let's go with array first. It says that I will hold two things. I will hold two things. I will hold a key. Okay, I will hold a key. Correspondingly, I will hold a value. I will hold a key, and correspondingly, I will hold a value. I will hold a key. I will hold a value. So K1, V1, K2, V2, K3, V3. The criteria is just some part of repetition, guys, so that you can say if you this is totally repetitive. Otherwise, we can uh, jump to questions. Okay. uh, but yeah, a quick revision. So k, the key should be, what is the rule for key, guys? की के लिए क्या क्या रूल है? It should be unique. uh, are you getting the point, guys?
Yes.
ठीक है. So these are the methods we'll be using and the keys which are unique. ठीक है. And the point is, put operation is order of 1, get operation is also order of 1. So searching and insertion is order of 1 at this point. Contains key. You need to check this if this is order of 1 or not. Is empty, order of 1. We can obviously make a counter. Okay, and this is the thing we can do. Key set, It is obviously not order of one, it would be order of n, where it's a number of entries. So this is what we have in hash map. Okay, so यही है hash map. So these are the methods and these are the some rules we have to follow. Coming to hash map, the first question. Okay, the first question. Maximum frequency number. So you are given an array of integers that contains number in a random order. Write a program to find and return the number which occurs the maximum times in the input. Okay, so which occurs the maximum time in the input. So there is an array given with repetitive elements. Okay, it says that if this is the case and if two or more element contains two or more elements contains the maximum frequency. Okay, maximum frequency, return the element which occurs in the array first. Okay, so return the element which occurs in the array first. Okay. Okay, so the point is, um, we have this array and there are some repetitions over here. Okay, and then we have to return the number basically, or what we have to return. So return the element which occurs in the array. Okay, so we have to return the element which occurs in the array. Any guesses how we can use hash map over here, guys? All of you got the question first? Question clear? Hai? Repetitive elements, find the frequency. Okay, and whichever number has higher frequency, return it. If there are two elements with the same frequency, return which is coming first in the list. Any guesses? What can be done?
We can store the frequency for each number.
Okay, very correct, very correct. So we can store the frequency for the number. So I can say that, um, let's say this is the array. Okay, so let's say this is array. Okay. Okay. Now, uh, traversing over the array, I can say that whatever element is there, make the element as a key and its occurrence as a value. Again, I got this number, so I will check my hash map if there is a the entity updated. Check the hash map if the entity is there. No, have it. Just this, just this. We already have. We already have for two. We already have. Now I can just iterate over the hash map to get the frequency and return the element. Is it clear, guys? Guys,
Yes.
okay, okay, quick and simple. Let's just do one of them, and rest I guess you guys can do. Hash map problems are the this is the easiest topic of complete DSA. Okay, easiest topic. No recursion involved, nothing involved. Just couple of functions. That's it. Easiest topic. Nothing to do here. So let's just iterate over the um, array and use our hash map intelligence. So I can say that uh, if hash map. So where is the hash map? So import java dot util dot hash map. Okay, hash map integer. This is what we have. And finally, I can see that if hs dot contains key. Okay, so there is a function, we call it contains key, and let put that key. This function tells that if there is a key with the corresponding supplied object or not. ठीक है, तो इससे corresponding key है कि नहीं. If this is true, ठीक है, क्योंकि boolean value है, we just saw this function, ठीक है, contains key, ठीक है, and so if this is the case, ठीक है, अगर ये case है सच में, so we will say that hashmap.put, okay, we'll replace that entity with the same thing. So we'll put hashmap number, okay, plus hashmap.get will fetch the value plus one. Are you guys getting this? Now put is for making a new entry, okay, but similar keys cannot exist. It will just override, okay. hs dot get it is to get the value for corresponding key. So अगर ये key present होगी, so I will put this key again but with increased value, because there is one more frequency occurrence in the array. Is it clear, guys?
Yes.
ठीक है. Otherwise, what do I have to do? Else, what should I put?
Num, comma 1.
Correct. Very correct. So there's a single occurrence. That's it. Yeah, that is it. Now it's time we find our biggest occurrence. Okay. So I can say that import java.util.set. Set is one data structure which the good part for set is we do not have any repetition of any object. We can store any object in the set. I can say that hs dot key set. Okay. And set is equals to new hs dot key set, or whatever set we are getting. I'll just iterate over it. Okay. So int number from the set, and I can find the max value. Okay, max value. So I can say that max value. So which is basically okay. It's I will say max value, okay, and is equals to 0. This is what we have, right? So 0 to n, 10 power 8, and ठीक है. So the max value is 0. Or I can say I need to store two things. First, the maximum frequency, and second, the answer. So second, the answer. So answer is also to be there. Yeah. So let it be 0 or something something. So frequency is 0 and this is 0. So if max frequency, okay, so if max frequency is a lesser than, ठीक है, अगर जो frequency है current that is lesser than hs dot get hs.get, and the key we are getting, so we are getting all the keys over here. Okay, one thing you should be asking the question is, sir, why aren't you directly iterating on hash map? Why do you use a set and then again do this? Are you guys getting this question? Are you
Yes.
okay? Any answers? Who knows the answer? Because hash map is not iterable. Okay, you cannot iterate over it directly. Makes sense, guys? So that is why we are finding all the keys and we are just iterating in this fashion. Okay?
Okay.
So I can say that max frequency barabar hs dot get num. Okay, so now this is the maximum frequency now, and our answer becomes the number. Okay, so answer is our number now. Yes, that is it from this question. Nothing else. So return the number. So what we did, we stored the frequency against the sorry, we stored the numbers against their frequency. Okay, and whatever the maximum frequency is there, um, you are just like finding it out, and whatever be the answer, not num exactly, answer would be returned, right? I guess this should do the job. Let's see if we not run into error. So it says that wrong type of arguments required. Oh, so really sorry. We have integer slash integer. Keys and values. We are talking about keys and values. Okay, not just talking about keys. We are talking about keys and values. What is it? Package HS does not exist, and package package HS does not exist. Oh, really sorry. We do not need to create a new object, right? So we have a newly created object on our own. Let's try to run this. So two wrong answers. Okay, why are we getting wrong answers? First question is this. Second question, how to solve it. Remember this note, what it is saying. If two or more elements contained, okay, contained यानी कि like compete or fight or something. Okay, I guess this is the meaning, right? Content. Okay. Yeah. So fighting, right? So if this is the case, then we do not have any order over here. So that is the biggest problem we have here. We do not have any order. How to solve this ordering problem? Hmm. Because this will have no order. Any other solution? Okay. Now the documentation must be having one more thing. It is unordered also. Where does it say? It does not guarantee the order will be remaining constant over time. Ah, okay. Are you guys getting the point over here? Yes. Okay. So this is one problem. Now, do we have anything? Any variation of it? I remember there is a uh, tree map or something that sort of. Okay, so which will give us the order. Okay, so guess anyone how did you guys solve this problem? Okay, anyways, let's go for tree map. Let's implement map interface. Okay, so there's a map interface. It's like a queue interface. We already know about the a red black tree based navigable map implementation, natural ordering of it keys, and all those sort of things are there. But what's the implementation? What's the implementation? So tree map is there and map is there. Okay. Okay, so we directly have this tree map. Okay, so let's just do a single change. Replace this hash map with tree map. Any other changes? Tree map. Oh, okay. Time limit exceed because this has something not for this. Okay. So something inefficient is happening. Something inefficient. Remember, I told that the maximum iteration we can do is 10 power 7 to 10 power 8. Now I have this 10 power 8 thing over here. Okay. So any increase in thing and time limit is 1 second. Very deadly timeline. So we have to be very careful what we are using. Hmm. So that tree map is solving the problem, but again we are getting 5 6 as not accepted. Okay, one more way, guys. Listen to. Can I say that I will maintain a hash map. Okay, I will maintain a hash map with the orders. I will say 2 has order 1, 12 has order 2, 11 has order 3. Can I do this, guys? One more hash map. 2 has order 1, 12 has order 2, 11 has order 3, 6 is order 4. So when this thing occurs, when we have equal frequencies, I can just check the other hash map. So whatever be the youngest order, that will be my answer.
Could you change that answer into integer dot min?
Change that answer to integer dot min. Okay, this is the only thing, but this is max frequency 0. So anyways, this answer will be changed at least one time, right? Are you getting my point? So this if block will execute at least once because minimum frequency will be 1, but we have taken minimum frequency 0. So this is going to run at least once. So no issues here. The issue is of ordering. So I can take another hash map to store the order, and whenever I find equality, I can use that. Are you guys getting the idea here, guys? What I'm saying is, Store 2 and 1 means 2 has the first order, 12 has the second order, 6 has the third order. Now, whenever I have equal frequencies, I will check if which of them has the lower order. That will be my answer. Guys, are you getting this point? Okay, let's continue this tomorrow. Try to do this. Okay? Try to take another hash map and solve this problem. And yes, so hash map will be done, and then we'll be moving to priority queues. Okay, then DP, and finally we are tries and Huffman. Okay, and let me ask user for like what's the like we'll be taking the WebDM so that we can plan it accordingly. Okay, so this was all for today, guys. I hope you guys are like getting the insights for the data structure, and the questions are enough for interviews. Okay, and unless you are like applying for like say if you apply for any bigger fine companies, then also like um, some of the questions are already from there. Okay, their question set itself. So that is one thing. Otherwise, just try to analyze, do revision one time, two times, three times, and try to form concepts from it. Okay. Okay. So this was all for today. Any doubts, any discussions? So if you want to have, please go on. So but before you go, today is 9/7 and 22. Guys, anyone remember when we started exactly? In which month? March or April?
March.
So we started in March. Oh, okay, makes sense. Okay, thank you so much, guys. Please mark your attendance and let's meet tomorrow. Okay, guys. Bye.
Thank you. Bye all.